So this is example 1b, and in this example we're going to work out the shear force and bending moments of this beam. So we'll start by taking the moments about B to determine the reaction force here at RA. So that's reaction force RA, and that's the reaction force RB. So if I take the moments about B here, so if we look at the clockwise moments, we have this. Okay, so that's 3 by 2 is 5. 5 times RA, so we get 5 RA plus the other clockwise moment is this one here. So that would be plus 1 times 10 kilonewtons. And that should be equal to the anti-clockwise moments. And the anti-clockwise moments in this instance is this distance here, which is 3 by 6 kilonewtons plus this over here, which is 3 and 2 is 5 and 2 is 7 plus 7 by 5 newtons. And if we solve that, we will get that RA is equal to 8.6 kilonewtons. Okay, if I then take the moments about A, and maybe I'll do this in a different color. So we do it about A, and again, if we take the clockwise moments, so we have this one. So that's 2 by 6 plus this one here, which is 2, 3 is 5, 1 is 6, plus 6 times 10. Okay, that should be equal to the anti-clockwise, which would be this one here, 2 by 5. And what else is going anti-clockwise? The RB. So it's plus 5 times RB. And if I solve that, I'll get RB equal to 12.4. And we can do a quick tot on that. So 8.6 plus 12.4 is equal to 21 kilonewtons. So that's going up, and coming down we have 5 and 6 is 11. 11 plus 10 is equal to 21. So 21 going up, 21 coming down, so everything is fine. Okay, so we have RA and RB. So if I want to get the shear force and bending moments, I'll take a segment. So let's take this segment here, just in here. So the forces, and we only take the forces now acting on one side. So the force here is 5 kilonewtons going down. So segment from C to A, the shear force is equal to minus 5 kilonewtons. And the bending moment, well, it's going to, if this is x, that distance is x, it's going to be minus 5 kilonewtons x. So that's the shear force and bending moment for there. If I take a segment between A and D, So we'll say segment A to D. Maybe I'll change the color on this. So now the shear force V from A to D is going to be equal to, well, we have all the forces to the left here. That's minus 5 kilonewtons plus RA here is 8.6. So that gives us 3.6 kilonewtons. And the moment from A to D. Okay, so we have that force acting at that distance, so we're calling this distance x. So we have minus 5 kx plus, and then we have this moment here. So well, if that distance is x and this distance here is 2, then this distance here is x minus 2. So it's minus 5k times plus 8.6 x minus 2. And if we multiply that out, we get minus 3x minus 17.2. So that's the bending moment and shear force there. If I want to work it out what it is between D and B, well, let's change the pen color. Right, so we'll take a segment here. So let's look at all the forces to the left of here. So we have minus 5k plus 8.6k, and then we have minus 6k. And when we add them all up, we get that's to be equal to minus 2.4. So we'd say the shear force from what's that, from D to B is equal to minus 2.4k. And now if we want to get the bending moment from D to B, it's the sum of all the bending moments to the left. So if this distance here now, if that's now x, well, it's minus 5k times x plus 8.6k times x minus 2 minus that distance there, which is 6k times, well, if that's x and that's 2 and 2 is 4, that's x minus 4. And if I multiply that out, I'll get m dB is equal to minus 2.4k times x plus 6.8k. Okay, so that's the bending moment from D to B. And then if I want to get the final one somewhere out here, and let me change the pen color. So if we're looking at this segment and we want to get the shear force, so the shear force from B to E, so we're going to sum all the forces to the left. So that's going to be equal to minus 5k plus 8.6k minus 6k plus 12.4k, and that all equals 10k. And that shouldn't be a surprise because that's the value here on the right hand side. And if I want to look at the moment from B to E, I can do the same thing. So it's now minus 5kx. This is now x plus 8.6k times x minus 2 minus 6k times x minus 4 plus 12.4k times x minus 7. And when we multiply them all out, we get that's equal to minus 10x minus 80. Okay, so now we have the shear force and bending moments at each one of the points. And let me just write them down a little bit more neatly. All right, so that's everything recorded here. So we have RA is equal to 8.6, RB 12.4. We have our shear force from C to A, our bending moment from C to A, shear force from A to D, bending moment from A to D, shear force from D to B, bending moment from D to B, shear force from B to E, and bending moment from B to E. And if I was to graph them, I would get something like, so the shear force. So from A to C to A is minus 5k, so it'll be down here, minus 5k. And then it'll run along for 2 meters. And then it would be 3.6k. That's that value there. And then it'll run along till it hits the 6 kilonewtons. And then it drops down to minus 2.4. Then it goes along till it hits the 12. And when it's 12, it goes back up to 10. And then it hits the 10 kilonewtons and it comes all the way back down. So that's point C, that's point A, that's point D, that's point B, and that's point E. So that would be the shear force diagram. And then the bending moment diagram, we would, it'd be something like this. This is minus 5kx. So as x gets bigger, it gets smaller. In fact, we'll do this. We'll do this in another video. Okay.